The next two terminal element that we will study is an ideal independent voltage source. The symbol for the source is shown on screen. It consists of a circle with a plus sign written next to one end of that circle. The value of the source is E of t and is written next to the source symbol. The voltage across the source is shown as V of t, and it is customary to use the same polarity for the reference direction of V of t to be the same as the voltage source. Once the voltage direction is specified, the current will flow from positive towards the negative end of the voltage and is shown on screen as well. The value of the source, E of t, may be equal to, for example, 5 volts, in which case E of t is also equal to V of t. The main characteristic of an independent voltage source is that the value of E of t is specified and is given. The current I of t that flows through the source can have any value, and it depends on what else is connected to the source. The example of the voltage source that we have given does not change with time and is fixed. Another symbol for such a source is to draw the following symbol connected between A and B and show the voltage right next to the symbol. This symbol is used specifically for what is known as a DC source, which is a source that does not change with time. If we plot the characteristics of the source on a graph where we have the current I of t on the x-axis and the voltage on the y-axis, then this graph will look like a horizontal line parallel to the x-axis, and the value of that source will be 5 volts. Once again, note that the value of the source is a constant 5 volts and the current through that source can be anything depending on what else is connected to the source. If the value of the source changes with time, for example E of t is equal to 5 sine of t, then once again the value of the source is specified and the current through the element can be any value, again depending on what else is connected to the source. Since the source changes with time, the horizontal line or the characteristic that represents the source will also change with time. Once again, if we plot I of t on the x-axis and the voltage on the y-axis, then at t is equal to 0, the source will be a horizontal line which corresponds to with the x-axis. We will denote this with t is equal to 0. At t is equal to pi by 4 seconds, the value of the source will be approximately 3.5 volts and the characteristic will be shown. At t is equal to pi by 2 seconds, it will reach the maximum value of 5 volts. And so on. At t is equal to 3 pi by 4, it will reach 3.5 volts again. This process will continue and the value of the voltage source will keep changing with time and the characteristics will be changing with time as well. Once again, the key idea is that the voltage of the source is known or specified and the current through the source can be any value. Since the voltage V of t and I of t follow the passive sign convention, the power absorbed by the source will be the product of these two variables, V of t times I of t, or the power supplied by the source will be the negative of the power absorbed will be equal to minus V of t multiplied by I of t. Note that for the sinusoidal source, the value of the voltage V of t is equal to 0 for t is equal to n pi, and the characteristics coincides with the x-axis as shown above and repeated here. This is the same characteristic as a resistor of value 0. Thus, a voltage source of value 0 is the same as a short circuit, and we will be using this property later on in this course. The source that we have considered so far is an ideal voltage source. Next, we will look at an actual voltage source that we will use in real life. The characteristics of an ideal source are shown once again, where the voltage is constant or known and the current can have any value. The ideal source is absorbing power in the right half plane, and the current is greater than or equal to 0 in this side of the plane. In the left half plane, the source is supplying power and the current is less than 0. An actual source has a slightly different characteristics, such that when it is supplying power, the voltage tends to drop as the magnitude of the current it is supplying is increasing, and the voltage across it increases as it is absorbing power. Normally, the value specified for the real voltage source is when the current is equal to 0, where the real and ideal voltage sources will have the same voltage value across it. A real voltage source can be modeled as an ideal source with some other elements connected to it,